Everyone. So today I'm want to share what I learned from three articles I read this week. All of them were about cloud computing. I know I might sound a bit technical, but once you break it down, it is really simply straightforward. I'm going to walk you through all articles, each one by one, explaining what they are saying in plain English, and then tell you what I personally took away from all of it. So let us get into it. The first article is about what cloud computing really mean, and it was written back in 2008 by two tech journalists Eric Knorr and Galen Grumman. So the first thing they point out is actually something I find really relatable. Nobody could agree on what cloud computing even really mean back then. Everyone had different definition. This still happens today a lot of with a lot of buzzwords, but here is how they explained it simply. Computing is basically is a service you use over internet where you are not running any software or any kind of computation on your computer, but you are not paying for the whole thing upfront. You just pay for what you use when you use it. They broke it down into seven types, but I will not go through all of them. But I'll explain the ones that stuck with me, which were the first SaaS, software as a service. This is the thing like Google, Gmail, and Google Docs, Netflix. You use them through your browser. You do not install anything. You just run their software on your devices. That's called SaaS. So the second is platform as a service. This is for developers. It's like renting the whole workspace in the cloud so that you can build and test your applications without setting up your own servers. And the third is utility computing. This is exactly it sounds like. You rent computing power the same way you use electricity at home. You pay for what you consume. What I liked about this article is it made me realize cloud computing is just not one thing. It is a whole family of services. And back in 2008, it was already becoming the future. So the second article is about cloud computing, a prospective study by Wang Von Lasuki, Kunze and Tao in 2010. Okay, the second article is a bit technical and more academic. It is called Cloud Computing, a Prospective Study, and like it was written by the researchers from two universities, from Rochester Institute of Technology and Karlsruhe Institute of Technology. So let's get into the main point. What I really found interesting is that uh, so what they did was they basically tried to answer the question what actually is IS cloud computing technically, and they gave what I think is one of the clearest definition I have ever read. They described a cloud computing as I'm paraphrasing here, a set of network enabled services that are scalable, affordable, and available on demand, accessed simply through the internet. What I really found is that they grouped cloud services into four categories. They call them HaaS, hardware as a services, SaaS, software as a service, DaaS, data as a service, IaaS, infrastructure as a service. And this showed how each one builds on top of each others. Think of it like HaaS is a physical machines, SaaS is a software running on those machines, data is the data you store and access, and IaaS brings it all together as one complete package you can subscribe to. They also explained what makes cloud computing different from older tech like grid computing. The big difference: cloud computing does not force you to learn new tools or change how you work. You just open your browser, log in, and it works. That simplicity is a massive deal. And they listed the key enabling technologies: virtualization, web services, and something called MapReduce, which is how Google processes huge amount of data, and even Web 2.0, which is basically the interactive internet we all use today. My key takeaway from this one: The researchers gave the technical backbone. It helped me understand why cloud computing works, not just what it is. So, to talk about the third article, the cloud computing concepts architecture challenges, written by Jadeja and Modi in 2012. What I liked about this one is that it takes a really complete view. It goes from history to how cloud systems are built, to the advantages, and then most importantly, to the problems. Starting with history, did you know the idea of cloud computing actually goes all the way back to 1960s? And a computer scientist named John McCarthy suggested that cloud computing could one day be organized as a public utility like electricity, gas, gas bills, and honestly, this is exactly what it has become. The paper explains the architecture. A cloud system has two main parts: the front, which is what you and I see on our browser, our app, our screen through which I'm interacting, and the back end, which is a massive infrastructure of services, storage, and data centers running behind them. There are a lot of data centers out in the country everywhere. We can like Google them and see what they are. They are connected through the internet, and a central server manages everything in between using something called middleware. They also talked about three types of cloud deployment: a public, private, and hybrid. Public means this is open to everyone, like think of it like Google Drive, Dropbox, very accessible but slightly less secure. Private cloud, this is inside one organization only, like a company running its internal cloud, like a company running its own internal cloud, more secure and more control. In hybrid cloud, which mixes both, you keep sensitive data on the private cloud and use the public cloud when you need extra computing power. The advantages that listed were like lower costs, easy maintenance, disaster recovery support, scalability, even environmental benefits like fewer physical machines means fewer electronic waste. But they were also honest about the challenges, like security and privacy are the biggest ones. When you move your data to someone else's server, you are trusting with them. That makes a lot of organizations, especially those with sensitive data, quite cautious. They also mentioned reliability concerns because even big cloud providers like Gmail has experienced outages. So what I actually take away from all three of these articles combined is, like, for me the biggest insight is this: cloud computing did not appear overnight. It was slow logical evolution from the idea that cloud computing could be used as a public utility in 1960s to the technical reality we have today, where I can store all my university assignments on Google Drive, OneDrive, and access them from my phone, laptop, and any computer in the world. What really hit me is how much of my daily life is already dependent upon the cloud. My emails, photos, streaming apps, university portals, all of it is cloud computing. I just never thought about the infrastructure behind it. From a software engineering perspective, what we are studying, cloud computing is incredibly relevant. When we build software projects, we do not have to buy physical servers anymore. We can just deploy our applications on platforms like Amazon Web Services or Google Cloud or Microsoft Azure and scale them up or down as we need. But the challenges the article raised, especially around security and trust, are things we as future software engineers need to take seriously. When we design systems that handles our user data, we have responsibility to do it safely. Overall, three articles, three different angles, but one clear message: cloud computing is not just a trend. It is the foundation of modern software, and understanding it properly is a part of becoming a better engineer. Thanks for watching. I hope it gave you a I I gave you a clear picture of what I learned this week. See you next time.